All right, so we are looking at the sprint round of the state competition for 2011 math counts. So we are starting with number 16, and we'll do a few, might skip around a little bit, but hopefully this helps. So first we're looking at number 16, which says square and a circle intersect, so that each side of the square contains a chord of the circle equal in length to the radius of the circle. So they're talking about this part right here and telling us that this part is equal to our radius, r. Okay, and then it's asking, the goal of this is to say, what is the ratio of the area of the square to the area of the circle? Express your answer as a common fraction in terms of pi. So let's look at this. This one has a few different ways that you could start looking at it. I started looking and seeing if there were equilateral triangles I could draw from our radius out. But really what this is trying to get you to do is see that when we extend from the middle, we can draw a radius that way. And when we extend again, we can draw a radius this way. So obviously, what we have is just our diameter, which is 2r. Okay? And then what we really need is the length of one of the sides of the square so that we can figure out the area of our square. So that length is actually the same as if I draw it right here. Okay? So that's what we need, and we actually have enough information to do that. We have our r, we have our 2r, and then we can figure out this side, and I'm just going to call it x. Just call it x. Okay? So let's try it. Let's use the Pythagorean theorem to figure it out. So we know the Pythagorean theorem tells us that a squared plus b squared equals c squared. So let's plug in some numbers. We know that for a, let's call that our x squared, plus our r squared equals 2r squared. Let's do some simplifying. So that we have 4r squared here equals r squared plus x squared. And when I subtract this r squared from here, I am left with 3r squared on one side and our x squared here. So that when I take the square root, all I'm left with is the fact that I have x is equal to the square root of 3 times r. And that actually tells me the length of this side of the square. We have the square root of 3 times r. Well, and that's great because we have a perfect square, so that we can just multiply that by itself to figure out the area. Now the ratio of the area of the square to the area of the circle, so let's start that over here. Area of the square, there we go, to the area of the circle is what we're looking for. So let's start with the square. We know that we have the square root of 3 times r, and that's squared because we need the length times the width, which is the same thing in this case. And for the square, we don't really have any dimensions, so all I can say is that it's pi r squared. So when I multiply out the top, I can figure out, well, that's just 3r squared, because the square root of 3 times the square root of 3 is just 3, and that's divided by pi r squared. Well, that just cancels out. So we're left with 3 over pi. So our answer up there is 3 divided by pi. Okay? Let's look at the next one. All right. In a rectangle ABCD, so let's draw that. We have a rectangle A, B, C, D. Point E is on side CD. And the area of the triangle ADE is 1/5 of the quadrilateral ABCE. Well, let's start setting this up. And it sounds like we don't really have much information about where point E is. So I just need to place it on my side DE, or DC. And we'll figure out a little bit more about it through this problem. Now we're looking at this triangle here. We have ADE. I'm going to draw that in orange. ADE. We're looking at that as a ratio, or we're looking at that and know that it's 1/5 of the area of the quadrilateral ABCE. So it's only that piece that we're looking at in comparison to our triangle. So what I did to do this one was set up my equations for the area of a triangle versus the area of a quadrilateral based on what I know. So I'm just gonna, I need some names though for my sides before I do this. And so I'm just gonna pick some random things. So let's call this side X, and this is Y. Let's call this Z. And then my height right here, I'm just gonna call H. So that I have names for everything so that when I put it in my equations, I can figure out what those are. So let's set it up. Our triangle, we know the area of a triangle is the base times the height divided by 2. So for this triangle, I have the base times the height divided by 2. Well, we know that that is 1/5 the size of our quadrilateral. And to figure out the area of a trapezoid like that, quadrilateral like that, we know that it's X plus Y, so base 1 plus base 2 times our height, and that's all divided by 2. Okay. Now let's just start simplifying. And before we do that, I just want a little piece of information out of my visual so that it'll help us in the future. And that's to say that Y, right here, is equal to X plus Z. We'll need that in just a little bit to help us simplify even more. So the goal here, we have 4 different variables. Really, I want to figure out what one equals. And it may be in comparison to another, but let's try to simplify to figure out what either Z equals or X or something like that so that we can get more information. So what I'm first going to do, I'm going to multiply by 2 on each side because it's a little bit easier to work with once that 2 is gone. So that I have ZH equals X plus Y times height over 5. Okay? Now I have H's on both sides, so I'm actually going to multiply each side by 1 divided by H. Or I could just divide by both sides by H. Same thing. Right? So that actually cancels out my H's on both sides when you multiply it out and cancel out. So that, let's go down here, Z is equal to X plus Y divided by 5. Now, I'm still working with 3 variables, so let's keep going. Let's actually use this piece of information up here to help us out. So first let's multiply by 5. It'll help us. So that we have 5Z equals X plus Y. Let's substitute that information in so that we have 5Z equals X plus what we have for Y up there, X plus Z. So when we simplify, we have 5Z is equal to 2X plus Z. Right? And lastly, what we can do is we can subtract Z here so that we have 4Z is equal to 2X. And I'm going to solve for Z in this case. Excuse me. We're going to divide by 4. So that Z is equal to X over 2. Well, that's good to know, because if we can say that right here is X divided by 2, then that helps me in my ratio, because I'm looking at the ratio That's this next part of our question. What is the ratio of the length of the segment DE to the length of the segment DC? So we're doing DE over DC. Well, if I can say that DE is x over 2, well, this whole side length is x over 2 plus x. That's what we named it. So that we can see that if I simplify and have x over 2, this actually simplifies to 3x over 2. Okay? There's a couple ways to simplify it from here, but probably the easiest to see is if I multiply each side, each top and bottom by 2 over 2, I can simplify these 2's. And if I do 1 over x over 1 over x, sorry about the mess, I can get rid of the x's. Or you can see that you have those in common, and that what we are left with is that 1 over 3. Okay? So when you simplify x over 2 divided by 3x over 2, you're left with 1 over 3. You can kind of see that because we have 1x over 2 in the top and 3 x's over 2 in the bottom. So the ratio that we have for those two line segments is 1 over 3. Okay? Let's try another one. Let's do number 18 now.